This is a pretty easy problem. So if we have a strong acid Ha and this neutralizes, so you have a strong acid Ha. So this is a strong acid, and after neutralization this acid releases a heat of minus 13.68 kilocalorie. At the same time, if we have Hb, that is a weak acid, so this is a weak acid, and this releases less heat. So weak acid releases only minus 2.9 kilocalorie per mole. So this is the heat released per mole in this case. So you see, in case of weak acid, heat releases less because of dissociation. So some of the energy goes for dissociation. And we have to find if I have one equivalent of NaOH, that is 1 mole of NaOH is added. So mole of NaOH is added. So if I have a mixture, so let us say I have a mixture and this mixture contains Ha plus Hb, and now if I pour NaOH from the top, and now this NaOH is added is 1 equivalent, and that is same as 1 mole. So now I can write mole of NaOH, this is equals to 1 mole, and this mole of NaOH is going to react, some mole will react with Ha and some mole will react with Hb. We have to find what are the percentage of Ha and Hb. So let us say mole of NaOH that reacts with Ha is a mole. So this means I can write mole of Ha, that is a mole. So now I can say mole of NaOH that has been reacted with Hb is 1 minus a, because both has to be 1. So mole of Hb that is equals to 1 minus a mole, because total reaction has been taken, that is 1 mole. So now I can say for 1 mole of Ha, what is the heat released? This is the strong. So for 1 mole of Ha, heat released minus 13.6. So a mole you will have heat released is minus 13.68 kilocalorie. For 1 minus a mole of Hb, the heat released will be this multiplied by minus 2.9 kilocalorie. Now what is the total heat released? That is the minus 6.9 kilocalorie. So I have to equate this with minus 6.9, and now let us solve for this. So I will have minus 13.68 into A and minus 2.9, and this is plus 2.9 into A. This is equals to minus 6.9. So now this is the only solving. So this side you will have, this side goes this side, so you will have 4, and if you take A common, so you will have minus 13.68. Of course this is minus 4 minus plus 2.9. So you can solve for, basically this is minus 4. So let us write this one. So this is minus 4. Are you getting? So this value is minus 4. Now let us solve for A. So if I solve for A, I will have 4. This divided by minus minus goes. So I will have 13.68 minus 2.9. So let us check this value. So I will have 4 divided by, so let us do this one, 4 divided by 13.68 minus 2.9. So this value is 0.371. So A is 0.371. So 37% around. So weak acid is around 37 points. So the A is a strong. So a strong acid is around, a strong acid is equals to 0.371 mole. Or in terms of percentage, I can say this is 37.1%. If you subtract from 100, you will get the weak acid. So let us calculate this one. So weak acid is 1 minus 0.371. So let us calculate this value. 1 minus 0.371 So this is 0.629. So this value is 0.629. So 0.629 mole of BKCD will have, and or you can say this is around 62.9%. 62.9%. So you can check the answer. You will have the same value, 0.629 and 0.371.